Good morning, seventh graders. I hope we're having a great start to our day and a great week so far. This week's video is going to be all about interpreting graphs of proportional relationships. So I'm really hoping that we can kind of connect some of our ideas that we've used before when it comes to looking for key features for proportional relationships in graphs, tables, and equations, and then extend it now interpreting it for other situations. So, without further ado, let's get to the video.
All right, seventh graders, let's talk about interpreting graphs of proportional relationships. Our first example, Grandma's special chocolate chip cookie recipe, which yields 4 dozen cookies, calls for 3 cups of flour. Using this information, complete the chart below. So let's start by creating a table. So I'm going to make F be my flour, and I'm going to make this really tiny, just that way it's easy for everybody to see. F is for flour. That's a bad looking F. That's okay though. F is for flour, and then we're gonna make D be dozens of cookies. Because who doesn't like cookies? So I know that for 3 cups of flour, I get 4 dozen cookies. So if I think about this in terms of a proportional relationship, that means I need to have a constant of proportionality that is going to continue to be 4 thirds or 1 1/3. So if I think about it this way, I know that if I double the amount of cups of flour, so if I have 6 cups of flours, that should double the amount of dozens, which is going to be 8. And if I double the amount of 6 cups of flour to 12, that also means that I can double the amount of dozens from 8 to 16. Is the number of cookies proportional to the amount of flour used? Why or why not? Well, yes, because 4 divided by 3, 8 divided by 6, and 16 divided by 12 all equal a constant of proportionality of 4 thirds. Let's make that a little bit easier. So, yeah. What is the unit rate of the cookies? Well, we just said that the unit rate of the cookies was 4 thirds or 1 1/3. And what is the meaning in the context of the problem? This is where we are really extending it this week. What is our actual meaning? So, it just means 1 1/3. That really doesn't look like a 3 in my denominator. Let's fix that. 1 1/3 dozen cookies per 1 cup of flour. Okay, so let's model this relationship with a graph. So let's see, I have 3, 6, and 12 are my points. So let's see, 1, 2, 3. I go up 4, 1, 2, 3, 4. This is my flour down here. And on this side is going to be my cookies. So that's 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Oops. Well, 1, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, 16. There we go, and now I'm going to make a line that fits all of that. Very good. So that's roughly how our graph is going to look. Does the graph show the two quantities being proportional to each other? Yes. And how do I know? Because it's a straight line. and goes through the origin. Zero, zero, which is this point down in here. Let me highlight it. How about that point? Write an equation that can be used to represent the relationship. Okay, this is taking what we learned back in our last lesson about writing equations. So what I can do is I know it's going to be dozens of cookies, and I know that it's going to be 4/3 is my constant of proportionality times the cups of flour. So 4/3 times the number of cups of flour is going to be D, or equals D. So D is dozens of cookies. And F is going to be flour. Okay, so that's our first example. This is kind of where we're going. We're trying to take a constant of proportionality, we're trying to take a proportional relationship and extend it to answer other questions. So let's try this again. Below is a graph modeling the amount of sugar required to make Grandma's special chocolate chip cookies. Okay, they already give us the graph, and they want us to record the coordinates from the graph. What do these ordered pairs represent? Well, first it's important for me to look at my axes to see what they're labeled. I have sugar, and then I also have dozens of cookies. Okay, so from looking at these points, I know I have the point 0, 0, which is 0 cups of sugar will result in 0 dozen cookies. 0 cups of, I'm going to make that S for sugar, equals 0 dozens. I have another 0.23, whoops, 2 cups of sugar equals 3 dozen. I have 4, 6, which is 4 cups of sugar equals 6 dozen. And I think you're kind of seeing where we're going from here. Okay. So Grandma has 1 remaining cup of sugar. How many dozens will she be able to make? And plot the point on the graph above. So this is where I want to start to think about, one, what is my constant of proportionality? Well, it looks like my constant of proportionality, or my K, is going to be 3/2. Okay? So I can look up here. If I have 1 cup, it looks like it's going to be roughly right there, which it looks like it's going to be 1.5 dozen cookies. Oops. Didn't mean to extend it like that. I can also think about it like this. If I use my equation from before, just similarly, knowing that my constant proportionality is different, this time it's 3/2, and my number of cups of sugar is 1, that's 3/2 times 1, which is the same thing as 1.5. So I know that I'm going to have 1.5 dozens of cookies. But it's really interesting. I see that at this point 1, I get my y value of 1.5, not quite on it, get my y value of 1.5, which is actually my constant of proportionality. I wonder if that's something to look out for. So how many dozens of cookies can Grandma make if she has no sugar? Can you graph this on the coordinate plane provided above? What do we call this point? Well, if there's no sugar, so 0 sugar equals 0 dozens. And we can call this the origin. Let's spell correctly here. The point is the origin. And let's go back up and let's plot it. that's going to be right there. All right, let's move on to the next problem, our final problem, really extending all of this together. So the graph below shows the amount of time a person can shower with a certain amount of water. So I see that I have gallons and I have the number of minutes that it takes to shower. So can you determine by looking at the graph whether the length of the shower is proportional to the number of gallons of water? Explain how you know. Well, in this case, yes, I know it's proportional. Yes, because it's a straight line. And goes through 0, 0. Next question. How long can a person shower with 15 gallons of water? And how long can a person shower with 60 gallons of water? So let's see here. Let's see if they answer that in our graph. So with 15 gallons of water, let's see what our scale is. A scale is how much we count by. So it seems like we're counting by fives. So 5, 10, 15, and I go up and I see that I can shower for 5 minutes. Oops. And 60 minutes is going to be, or 60 gallons is going to be 20 minutes, just from looking at the graph. So what are the coordinates of point A? Describe point A in the context of the problem. Well, I know point A, let's see, is going to be after 20, so it's 25, 30, so 30 and 10, 30 gallons of water in 10 minutes. So let's see, 30, 10. If there are 30 gallons of water, the handwriting is especially bad today. If there are 30 gallons of water, you can shower for 10 minutes. Can you use the graph to identify the unit rate? Well, let's see. I know that the line passes through the origin. So I'm betting that if I look at my 1 point, or if I try to look for my constant of proportionality, because 1 is going to be like way inside of here, right? But if I'm looking to see what my constant of proportionality is, so I know I have the point like 15.5, for example. If I do 15 divided by 5, whoops, I mean 5 divided by 15, I get 1/3. So I know that the point at 1 is going to be 1/3. And I know that my K value is going to be 1/3. So write an equation to represent the relationship between the number of gallons of water used and the length of the shower. Well, in this case, it's going to be the number of minutes you can shower equals 1/3 times the amount of gallons. Okay? And the point that I really want to hit home here is that, and this is easier to see here, when I am working with a graph, if I'm trying to find out what the constant of proportionality is, my constant of proportionality will always show up at the first 1 point. So K will always show up at whatever our X value is for 1. R is the value that they like to use, our rate. Okay? So I know that right here from my previous problem, that dot was at the point 1, 1.5. So I knew that my rate was 1.5. Let's go to our summary page. So the lesson summary. The point 0, 0 and the point 1 and r, where r is the unit rate, will always appear on the line representing two quantities that are proportional to each other. The unit rate r in the point 1r represents the amount of vertical increase for every horizontal increase of 1 unit on the graph. The point 0, 0 indicates that when there is 0 amount of one quantity, there will also be 0 amount of the second quantity. These 2 points may not always be given as part of the set of data for a given real-world or mathematical situation, but they will always appear on the line that passes through the given data points. So that's all that I have for this video today. If you have any questions, feel free to leave a comment in the comment section below. You can message me on Schoology. But until then, I hope that you all have a great day.